Hello friends, I'm Haresh Suthar. Today we'll understand the oscilloscope probe and its parameter. So this is one of the, you can say that, complicated part of the DSO. So we'll try to understand each of the component first, and we'll go into the details of usage of it and with its parameter of the probe. So here you can see that this probe is a passive probe. The name written here is a passive probe, and it is a 1x and 10x. Now here this is for 100 megahertz frequency application or frequency of usage. These probes can be used for maximum 100 megahertz frequency. Now there are various kinds of probes comes into the market, like active probe, then optical probe and linear probe and lot many probe. But today, as far as the discussion here is concerned, we are limited with the uh, explanations of the passive probe only. Now here you can see that it is 1x and 10x. Now we'll see that what is the what are the meaning of 1x and 10x. Now before we start, let us understand the components of the probe. Now this is nothing but a measuring tip. Now this, you can say that this is nothing but a measuring tip. Now this is a measuring tip. Now if you press here, the lead will come out and you can connect with the any of the component, electronics component or electrical component. Now this is nothing but it's a ground lead. This is called as a ground lead, so it must be connected with the ground. And this is nothing but it's a BNC connector. This is BNC connector, which is called as a bayonet navy connector, and this is the total length of the cable. Now everything matters here. Now here you can see this small hole here. Now we'll see the usage of this small hole. Now you can see the ring over here, which is called as a marker ring, and we'll also try to understand the application of what is the application of this thing. And for other part of the probes, that this is the marker probe. This is just to differentiate that the probe is for which range of the frequency, or it depends. I mean, it's up to the user that how uh, user wants to mark, I mean, use this color, marking color for their application. Now this is what in my hand is adjustment tool. Now this is used to adjust the uh, capacitor of the capacitance of the probe. Now here you can see that we have a this thing which is known as a electrical contact for grounding. Electrical contact for grounding. Now this is a specific uh, tips which are used to connect the CRO with the IC probes. So which is a specific kind of tip which can be connected over here within this, and from here you can connect the specific type of IC using this IC tip. This is called as IC tip. Now let us start from here. Now if you can see that there is something written on this probe. Now some data is written on the probe. Actually I'm not able to read it properly, but it is written as let me take another probe and let me try to read it. So it is written that it is 100 megahertz or 10 megahertz. 100 megahertz or 10 megahertz. If you see here, it is written that 100 megahertz or 10 megahertz, right? And it's a 10x for 600 volt peak. It is 10x for 600 volt peak, and 1x for 200 volt peak, and it is cat 2. So we'll try to understand each of this terminology in detail, because this is very important when we uh, deal with the oscilloscope, or you can say digital storage oscilloscope probe. So these are called as a probe parameter. Now the very first parameter which comes into the discussion is called as a attenuation of the in the probe. So the most important parameter which we have discussed is 10x and 1x, right? So here you can see that it is 1x and here it is a 10x. So basically 1 means there is no attenuation, and 10 means it's a 10 time attenuation, right? So generally see, sometimes you may have a 100x probe, but here in this case we do not have a 100x. So if it is 1x, 10x, I mean it depends that how much attenuations are possible with the probe. So depending upon that, they write into the data sheet. So we have just 1x and 10x. Now if you see the attenuation, then it is 1 to 10 or 1 raised to 10, means there is a attenuation. 1 means no attenuation and 10 means attenuation by 10. So what do you mean by that? So when I'll say that it's a 10x probe, means it will give a input impedance 1 by 10th. Input impedance will be 1 by 10th of the voltage, and I mean sorry, input impedance will be 10 times, and hence the voltage will be 1 by 10th. So as a result, what happens, that whatever is the, see, if you see here over here input resistance, it is a 1 mega ohm and 10 mega ohm. So 1 for 1 corresponding 1 mega ohm and 10 corresponding 10 mega ohm. So if I will make 1x, then it is a 1 mega ohm input impedance offered by this probe. And if I'll switch over to 10, then see how do we use this thing. So here there is a switch by using which you can switch over from 1x and 10x. It is already written over here. This is a 10x, this is 1x. So 1 corresponds 1 mega ohm and 10 corresponds 10 mega ohm. So input impedance offered when it is 1x, it is 1 mega ohm, 10 means it's a 10 mega ohm, and as a result 1 means there is no attenuation, 10 means there is a 10 times attenuations, right? So as a result voltage will be lowered by 10x. So higher attenuation probe allows the measurement range of the scopes to be extended, means you can measure more voltage using higher attenuations. But the disadvantage is if in the case of this more attenuation, the lower amplitude cannot be picked up. Now in that case, the, let's say there are some noise, lower noise, then which cannot be measured with the 10x probe, then you have to switch over to the 1x probe in order to measure the lower noise voltage, and then only you are able to see the lower noise signals. Now next is accuracy. So see, the accuracy is not written in any of this parameter, but this is very important parameter in the probe selection, because it indicates the voltage sensing capability of the probe. Because as I have told you that 10x will offer 10 times resistance, and 1x there is no resistance. So ultimately the accuracy depends on the input resistance. The most important is accuracy depends on the input resistance given in the data sheet. So depending upon the data sheet, input resistance, the accuracy, because lower the the resistance offered by the probe, the higher the capability to sense the low noise signals, because noise is very low signal. So this can be picked up easily if you have a input resistance or input impedance in terms of matching with the DSO. So accuracy basically depends on the input resistance. Now next is the bandwidth of the probe. Now see, this is also very important parameter, because in the case of bandwidth, as we know that, what do you mean by bandwidth is nothing but it's a 3 dB down, or the frequency at which the voltage start falling and it goes into the 3 dB down, or it's a 0.707 of its maximum value. So the definition of bandwidth says that the range of the frequencies for which voltage drops 3 dB down in terms of decibel, or 0.707 of its maximum value, is called as a bandwidth. Now this is a simple definition of the bandwidth. So here, let us say, if you have a DSO which is having a capability to measure, let's say, 200 megahertz signal, but your probe is not having the capability to sense that signal. Now in this case, if you see that it is clearly written on the probe that it can be able to sense up to let's say, for 1x it is 10 megahertz, and for 10x it is 100 megahertz. So similarly, if you see over here, so this is called as a system bandwidth. So depending upon different this thing models, so here we have a 3100, so it falls under this category. So in our case, for a 1x it can measure up to 6 megahertz, and for 10x it can measure up to 100 megahertz. So this is very important, because up to 6 megahertz signal, if frequency of the signal is up to 6 megahertz, then you can measure using 1x probe. But as the frequency increases more than 6 megahertz, you cannot use the probe in the 1x mode. You have to change the probe into 10x mode, and then you can measure the frequency up, and the maximum frequency which can be measured is 100 megahertz, right? So this is very, very important when you select the probe. Now a thumb rule says that the probe should be more than, or you can say at least 3 times more the bandwidth of the DSO. But it's okay if we have a 100 megahertz DSO and up to 100 megahertz is the capability of the probe. It's okay, but it should not be lower than that. That's the main important point or main important concern over here. So bandwidth is one of the most important parameter, wherein you cannot neglect it, or you have to be very cautious, and you have to see the specifications of the probe. Now next is cable length. Now if you see that it is given over here, I think length is up to 130 centimeter plus minus 1.5 centimeter. So it's length of the cable. So why I am discussing this parameter? Because length of the cable also offers the resistance. So see, you cannot have a probe which is more lengthy. See, these are the generalized probe. This 1.3 this is nothing but 130 centimeter is nothing but 1.3 meter probe. So generally the standard probe which comes into the market is 1.3 meter probe and 2 meter probes. And so if you want to measure the signal with a higher length of the probe, then you should be very cautious that it should match with the specifications of your DSO, because the greater the distance between the equipment and between the CRO and the point of measurement, the resistance is being added into series with the resistance of the wire will be added into series with the resistance of the this input resistance, and as a result it will have a more attenuation. Now next parameter is the CMRR. So this is also not written over here, a CMRR. But anyway, the CMRR is called as a common mode rejection ratio, and it is applicable only for the differential probes. So it is a measure of the ability of the probe to reject any signal that are common to both the inputs. This is called as a CMRR. Now next parameter is a compensation range. Now this is very very important, because this compensation range depends on this capacitance. So if you see that input capacitance is 1x, it is having a range from 85 to 111 picofarad, and 10x, it is 14.5 picofarad to 17.5 picofarad. So if you see over here, then for 1x the capacitance is more, and for 10x capacitance is less. So see, less the capacitance is desirable. I mean, it is good to have a less the capacitance. So for compensation range, as I have told you, that I do have adjustment tool, and from here you insert this thing, and you should adjust the value of the capacitance such that, now why you need to adjust the capacitance? Because if you see that this is a kind of waveform, let's say you are getting initially, this is the kind of waveform you are getting while testing the probe. Now how do you test the probe? So there is an inbuilt 1 kilohertz test signal is generated within the DSO or CRO. So you have to connect the your this inputs tip with the 1 kilohertz test signal, and you have to check the response of the signal in the on the screen. Now if you are getting this kind of signal or this kind of signal, means it's not pure square wave, then you have to adjust using this uh, adjustment tool, and you have to change the value of the capacitance such that the value of the capacitance matches perfectly. So this is called as a capacitance or a compensation adjustment. So this is very very important when you are using the DSO or CRO. Right, now why do we require this thing, that we'll discuss when we'll discuss about input capacitance. Right, so next parameter is regarding the terminology is being used over here, that is IEC 61010 and CAT2. Right, so this is nothing but it is a one kind of compliance. IEC is a one kind of compliance, and this IEC 61010 is a compliance by International Electrotechnical Commission, and basically it is used for test equipment, or you can say electrical test equipment. This compliance is being used. So this compliance must be followed when electrical test equipment is being used, and there is a CAT2. CAT2 means it's a category 2. Now whenever we are using a word CAT2, that means basically we are using a single phase receptacle connected loads. So in a CAT2 we are assuming that we are dealing only with a single phase supply, and that also all the tools and equipment which we are handling are equivalent to the household loads, instead of industrial loads. So CAT2 is basically for single phase and household loads we are assuming. Right, so this is very very important, because in I'll tell you exactly that what is the uh, load which is being used in CAT2. As I have told you that it's a household, but to be specific with the energy in a CAT2 installation should be limited to below 100 ampere for a continuously, or below 500 ampere for a voltage not exceeding 150 volt. So a maximum is see here for 1x it is 150 volt AC, and 10x it is 300 volt AC. So that means see, if this is for voltage, but if it's a current passing through this thing, then it should not be more than 100 amperes. So current should be less than 100 ampere, and that is up to 300 volt. But if current is more than 500 ampere, then voltage should not be more than 150 volt. So this is what limited I mean, these are the specifications for cat 2. As for this thing, this is given by NEPA, which is called as National Fire Protection Association, which has given this category cat 1, 2, 3 and 4. So we are not going into the other categories like cat 1, 2, cat 2 we have discussed, but not go into the detail of cat 1, 3 and 4. You can refer the uh, any of the literature for that. Now next is the input capacitance, which is C in. Now this is also very important. C in, if you see over here, then for 1x it varies from 85 to 101 5 pf, and for 10x it varies from 14.5 to 17.5 pf. Now this is input capacitance of the probe. So it depends to some degree on the capacitance of the scope and the adjustment of the probe capacitor, because as we have seen that we can adjust the probe capacitor from here using the tool. So excessive input capacitance, this is also called as a lead capacitance. Ultimately this is called as a lead capacitance. uh, so it is not desirable because it slows down the system's pulse response. So it is desirable that this the lower the capacitance, better the probe. This is what general thumb rule is. Now next is input resistance. So here you can see that this probe is having a 1 mega ohm and 10 mega ohm input resistance, and the wire length is also having some resistance which adds in series with this resistance. So input resistance, so generally the probe comes with the two types of input resistance category. One is 1 mega ohm and another is 50 ohms, right? So you might have heard about that 50 ohm is the input resistance of the probe, and now this is 1 mega ohm input resistance of the probe. So typically there are 50 ohm probes, and this is what um, you can see over here. It is a 1 mega ohm probe, but see this resistance should match with the input resistance of the DS or system at which we are connecting the probes. Now see, this probe is having both resistance and capacitance. So if you try to measure higher frequencies, so as and when you move from lower frequency measurement to higher frequency measurement, then in that case uh, the value of the capacitance will offer more impedance. Now in that case it's nothing but ultimately it will keep on adding more impedance, and which which may affect the results of the measurement. So it is desirable that probe should have a, when you have a higher frequency measurement, then that's why I've told you that this capacitance should be as low as possible, because higher the capacitance value, more the impedance being offered, and that comes into the parallel with the resistance, and as a result the total resistance decreases. So let's say here you have a 1 mega ohm, and impedance offered by the higher frequency is very high, then both are in parallel, so total resistance is again decreases. So it is desirable that the capacitance should be as low as possible. Now next is regarding this voltage capacity, that already we have discussed that for 1x it is 150 volt AC, and for 10x it is 300 volt AC. Now maximum working input voltage, so for 1x it is less than 200 peak, and for 10x it is less than 600 peak value. Now this is, we are talking about peak to peak, right? So for peak to peak value, it should not be it should be less than 200 volt for 1x, and it should be less than 600 volt for 10x. Now next is a probe termination, that already we have discussed that there are two types of probe termination with the DSO, that is 1 mega ohm, 10 mega ohm, or 50 ohms. So depending upon that, you have to match R and C value of the oscilloscope such that the probe resistance should match with the resistance of the oscilloscope. Now next is readout detection, which is another parameter. So it is basically detect the attenuation level. So generally readout detection is measured with reference to the attenuation, and it should ensure that the scope and probe are incompatible. Then you should have a better readout. Now another is a rise time, which is called as a, this is a standard definition for the rise time, is a time required for a signal to rise from 10% to 90% of its or you can say for a pulse to rise from 10% to 90% of its final value, so which is called as a rise time. So you can measure all this parameter using the DSO, but this is a particularly a part of the parameter of the probes. So I think we have already discussed the main and important parameter of the probe. Now next is weight, length, operating temperature -10 to, you can use up to plus 70 degree, humidity up to less than 85% relative humidity. So major specifications of the probes we have already covered. So this is one of the most important part of the DSO, or you can say oscilloscope, wherein you should be very uh, careful when you measure the signal. So you should be aware about the type of the signal, and if you are not aware, then you should vary the value of capacitance and try to read. And before working with the DSO, it is important that you should understand the characteristics or parameter of the probe very well. Then and then you should start working with the DSO. Thank you.